When looking at any hypothesis test question, the main idea is to figure out what type of test you'll be doing. And so the first thing is to identify what parameter you're testing with, and then the second thing is what conditions must hold to test with that parameter. And so both of these examples that I'm going to do are with the mean, but for the mean we have two tests, the z-test and the t-test. The main difference between them is for the z-test you have to know sigma, and for the t-test you don't. So here in example 1, we're told we have a sample of 40 pump purchases, so that means we have a sample n equals 40. And the average amount was 10.4 gallons. Okay, so X bar for that was 10.4. The population standard deviation is assumed to be 1.2. Okay, so that's actually sigma. The population standard deviation is sigma. If sigma is known, it means we're going to use a z-test to test the question about the mean. And so we want to know, is there evidence the average purchase is more than 10 gallons? So the claim we're trying to test is that the average is more than 10. So all this information kind of helps me identify what type of test am I going to do and what information do I need. And so the first thing I'm going to note is that even though our sample, the sample mean was clearly bigger than 10, that doesn't mean it's true for the whole population. All that means is that in this one random sample, you happen to be bigger than 10. The question is, can we take that sample and say, okay, because of this sample, the whole population, the mean for everything would be bigger than 10. And it depends on many factors. And so what we're going to do is use a hypothesis test to determine if that's strong enough, if the sample is strong enough to make that determination. So, okay, so H naught and HA, always set this up first. Our claim doesn't have an equality, so it's going to be HA. And that means the complement is going to be H naught. All right, so my next step is to calculate a p-value. The p-value method says calculate a p-value and compare it to alpha. And so in this case, our alpha, also known as the significance level, is 5%. So alpha equals 0.05. So if p is smaller than alpha, I'll reject H naught, and if p is larger than alpha, I'll fail to reject H naught. So what I want to do on the calculator is actually what's called a z-test. And so I go to stat on the calculator, I go to test, and then the information it's going to ask me, the first thing it asks for is mu naught. Mu naught comes from the H naught, and so that's going to be 10. Notice also that it asks for sigma. Sigma is 1.2 in this case because that's the population standard deviation. So if it asks for anything else, I would know automatically that I'm doing the wrong test. And now once the sample mean, of course, that's 10.4. It's all asking for information that it needs to calculate a probability. And then also notice that it asks for what tail test it is. And this is a right tail test because HA is greater than. So I calculate this p-value, and I find that the p-value is 0.0175. Okay, so comparing this to alpha, this is definitely smaller than alpha. And so that means my decision is to reject H naught. Okay, now of course that isn't everything. A computer could do this part. The question is, what does that actually mean? If I reject H naught, remember the process is that I assume H naught is true. I look at the evidence, which is kind of like the p-value here, and I determine is there evidence to change my mind. And when we say reject H naught, we say yes. And so it means I'm liking HA right now. So I want to make sure I answer the question, but also realize I'm saying yes, there's evidence that means more than 10. So I come up here and the question is very straightforward. Is there evidence the average purchase is more than 10 gallons? I would be able to say yes, there is evidence the average purchase is more than 10 gallons. Now you may be asking yourself, how could you have it where you have a sample size or a sample where it's more than 10 and you conclude that the population probably isn't? A lot of it comes down to the standard deviation. If the standard deviation is pretty large, then even if my sample happens to be bigger than 10, I say, well, that could have happened. And then the other question you might have is, what does this p-value mean right here? So what does a p-value really represent? It's very important to understand this because many people misinterpret the p-value, even people who are scientists, and studies have been done where doctors even misinterpret the p-value. What this is saying is there's about a 2% chance of a sample like this. And what I mean by a sample like this is a sample as extreme or more extreme, so of 10 or higher, 10.4 or higher, if we assume H naught is true, and not just H naught, but the equality statement of H naught. So if we assume that the mean equals 10. So in other words, we're saying it's a very small chance that you would see a sample like this in that case. Therefore, I question that assumption. And so I change my mind. I say, you know what, that's probably not a true assumption. So I change my mind. That's the general theory of hypothesis testing, at least with the p-value method. Now, the other method, the only thing that will change is this step. Everything else will stay the same. We'll be rejecting or failing to reject. We'll be setting up and choosing our test, etc. So let's take a look at one other example using the p-value method. Okay, so in this example, we're told FICO scores range from 300 to 850, although I think they recently changed this range. And the population mean is 703.5, so that's for everybody. And analysts wondered whether individuals with high incomes had a different mean credit score. So what does he do? He takes a sample. Okay, so we have a sample of 41 high-income individuals, and the average for them was 714.2, which is obviously higher than 703.5. And the standard deviation, though, was pretty high. Now, this standard deviation, referring back to the sample, so this is S, is 83.2. And so we want to conduct at alpha equals 0.05 a test to determine if high-income individuals have a different mean credit score. Well, first of all, the question is, how do you test something's different? Well, mathematically, to say something's different, we say it's not equal. So the claim that we're testing is that the mean for high-income individuals is different from the mean for everybody else, which we know is 703.5. And now the question is, what test do we use? We don't know sigma. The standard deviation we have is for the sample. If sigma is unknown, that implies that we use a t-test. Same rules as confidence intervals. Okay, so if we're going to use a t-test, what that means is our p-value is going to come from the t-distribution. Everything else stays basically the same. So H0 and HA, this is a two-tailed test, so it's going to be mean of high income equals 703.5, and the mean for high income does not equal 703.5. And then t-test on the calculator is under the same menu. And so when I go here, notice that it asks for the same information, so mu naught, that's 703.5. As for sample information, specifically, it asks for the sample standard deviation. This is one way to keep track of which is the right test because remember the z-test asks for sigma. And so the calculator knows which method is appropriate. When I go through and calculate this on the t-test, so I enter all my information, I get down to calculate, I end up with a p-value of 0.4151. This is a rather big p-value. This is certainly bigger than our alpha. This is a big p-value. It's telling me there's a 40% chance, more than a 40% chance of seeing a sample like this if the real mean for high-income people is 703.5. So it's saying this is not an interesting sample, and therefore I should fail to reject H0. Anytime the p-value is bigger than alpha, you fail to reject H0. So what that means is I assumed H0 was true. You couldn't change my mind. So I didn't prove H0 is true because I assumed it, right? I didn't prove the mean for high-income people is 703.5. I just said you didn't prove it, is it? That may sound like lawyer speak almost, but really we have to be careful about what we proved and what we didn't prove. So all I can really say here is there's no evidence the mean for high-income individuals is different. So the interpretation is probably the most important part. When you're writing a research paper or a paper for your bosses, when you're trying to come up with a new marketing plan, the conclusion from your test is what's most important, right? They don't really care about all the methods you used, although they should certainly be right, otherwise your conclusion's wrong. But they say, well, what should we do? What can you say about this data? And that's why this interpretation is really the most important part. And so again, notice the process stayed the same, just the test changed. I set up my H9HA, found my p-value, compared to alpha, made my decision, and then interpreted.